Today we'll see some more problems on formation of PDE by eliminating arbitrary functions. Okay. Take one problem. Z is equal to f of xy divided by z. Okay. So calling the problem as 1 and taking partial differentiation of 1 with respect to x. Okay. So left hand side will be del z by del x, nothing but p, and differentiation of f of xy by z, differentiation of the function will be f dash, and the terms inside the bracket will be as it is, and with respect to x you are differentiating 1, so y will be constant. And as you already know, z is a function of x and y. After writing constant y outside, x will be present in numerator and denominator both, because in the denominator z is present and z is a function of x and y. So if x is present in both numerator and denominator, you need to apply u by v rule for differentiation. Okay, so after writing differentiation of the function as f dash and taking y and writing y constant outside, you need to apply u by v for x divided by z. And you already know u by v rule is v square in the denominator, v into differentiation of u minus u into differentiation of v. So if we apply the same for x by z, z square in the denominator, z into differentiation of x with respect to x is 1 minus x as it is, differentiation of z with respect to p will be with respect to x will be p. Okay, so the answer for quotient rule is u by v rule is z minus xp divided by z square. Okay, and now simplify this expression, and simplify in the sense you solve for f dash of xy divided by z. So remaining terms you cross multiply and call it as equation 2. And now in case 2 we will consider partial differentiation of 1 with respect to y. So left hand side will be del z by del y, nothing but q, and differentiation of the function will be f dash. Okay, and the terms inside the bracket as it is, and with respect to y you are differentiating, so x will be constant. So in xy by z, x will be constant outside, then you need to apply chain rule for y by z. And again z is a function of x and y both, so y will be present in numerator and denominator, so you are applying quotient rule again. Okay, u by v rule. So v square in the denominator, that is z square, v into differentiation of y with respect to y is 1 minus y as it is, differentiation of z with respect to y is q. Okay, and again solving for f dash, cross multiplying other things, you will get equation number 3. And now you can see in 2 and 3 f dash is present in the RHS. So on division, that is 2 divided by 3, you can easily cancel f dash. Okay, remaining terms you write and simplify. On cross multiplication you will get pz square divided by zy minus xyp equal to qz square divided by xz minus xyp. On cancelling z square and simplifying, you will get pxz minus qzy as the answer in the sense PDE. Okay, and now next problem, z is equal to f of y plus x plus g of y plus 2x. And again writing the problem once again and differentiating the problem z with respect to x. So p will be f dash of y plus x, and with respect to x, y is constant, so differentiation of y is 0, differentiation of x is 1, plus as it is, differentiation of g with respect to x is g dash, the terms inside the bracket as it is, and differentiation of y with respect to x is 0, and differentiation of 2x is 2. So p will be f dash of y plus x plus g 2 into g dash of y plus 2x. And now considering partial differentiation of z with respect to y, that is q. So f dash of, in the RHS, f dash of y plus x, and partial differentiation you are writing with respect to y, so x will be constant, so differentiation of y will be 1, differentiation of x will be 0, plus differentiation of g function is g dash, terms inside the bracket as it is, and with respect to y you are differentiating, so differentiation of y is 1 and this will be constant, differentiation of constant is 0. So now you can easily observe you cannot remove the function, arbitrary function, from these two. If you simplify this on addition or if you do subtraction, then you can cancel f dash. So the function will be, the answer will be in terms of g dash. Okay. So by using these two, you cannot remove arbitrary function. So you need to think of double derivatives, nothing but r s t. So r will be zxx, meaning partial differentiation of z twice with respect to x. Okay, one time differentiation in p you have written. So if you differentiate p, nothing but zx. Okay, if you differentiate p one more time with respect to x, it will give you r. So partial differentiation of z twice with respect to y will be zyy, nothing but t. So one time differentiation is already here, so you can differentiate q with respect to y to get t. In the same way, differentiate q with respect to x to get s. Okay, now r you write. So r in the sense differentiation of p, f double dash of y plus x plus 2 as it is. Differentiation of g dash will be g double dash. With respect to x you are differentiating, so differentiation of 2x will be 2. So 2 into 2 it will be 4. So you will call it as equation number 1. And then in s you will write s in the sense differentiation of q with respect to x. So this differentiation of f dash of y plus x will be f double dash of y plus x plus differentiation of g dash will be g double dash, and with respect to x you are differentiating q, so differentiation of 2x will be 2, calling it as equation 2. And now writing t, meaning differentiation of q with respect to y. So f dash of y plus x differentiation is f double dash of y plus x plus g dash differentiation is g double dash of y plus 2x. With respect to y you are differentiating, so differentiation of 2x will be 0, differentiation of y will be 1, and you are calling it as equation number 3. Now you got 1, 2, 3 in terms of f double dash and g double dash. And now easily you can take 1 minus 2. So if you take 1 minus 2, you can cancel f double dash and you can write the answer in terms of g double dash. Okay, calling it as equation number 4. Again consider 2 minus 3, so s minus t. So here again you can cancel f double dash and the answer you can write in terms of g double dash, and those two equations you are calling as 4 and 5. Okay, and now you can easily see g double dash present in the RHS of 4 and 5. So on division you can easily remove that function. So 4 by 5 if you consider r minus s divided by s minus t is equal to, on cancelling g double dash you will get only 2. So on cross multiplication and simplifying you will get r minus 3s plus 2t as the partial differential equation after removing f and g from the function. Okay, and now try this problem. Okay, so solution is also here.